So we are covering a topic today called mean absolute deviation. Once we cover this topic and do a couple practice problems, you're going to take your scatter plot and mean absolute deviation exam. It will be an open note exam, so make sure you actually take good notes on this so you can actually use them for the test today. So label your notes, mean absolute deviation, mean absolute deviation. Okay, before we even start, let's talk about mean absolute deviation, what that means. The word mean, what do y'all think about when you hear the word mean? Good, average. So I'm gonna like annotate this. So mean means average. The average of all my numbers. Okay. Absolute. Absolute. Anyone remember what that means? Think back to 6th grade. Absolute. Perfect. The distance from 0, like the true value. So you think of absolute value of a number. So it's like the only the positive that gives you the positive. So the distance from 0. So I'm just gonna put absolute value. Absolute value. So if you remember, those are those bracket lines. So like if I had a number. Okay, deviation. Does anyone know what that word means? Deviation. Have you ever heard someone like say you're deviating from something? Deviation. So deviation is like the distance. So by breaking down each word, we're basically talking about what the definition of mean absolute deviation is. It's the average distance each point in a data set is from the mean of the data. That's a lot of words, okay? But it's the definitions right here. The average distance each point is from the mean of the data. The average distance each point is from the mean of the data. The average distance each point is from the mean of the data. And don't worry, I'm going to show an example and I'll explain the definition as we're doing the example. The average distance each point is from the mean of the data. So, for example, let's say I asked all of you what your weight was, how much each and every one of you weighed, okay? So I got all of your data points. Every person, y'all are all 13, 14, right? Okay, so I'm gonna see how much on average a 13 or 14-year-old weighs. And then, so then I'm like, okay, Jesus, well, how does your weight compare to the average of the class? Well, I would be taking his weight, and seeing how it compares to the average. And then, okay, Emily, how does your weight compare to the average? And so I'm taking each person's weight and seeing how much it compares to the average. And then I'm taking the average of that number to see how far each person's weight is from the average weight of the class. So what we're going to do is look at some data sets, look at some numbers. Go ahead and write these numbers at the top of your paper. And these are random numbers. I chose random numbers. They don't mean anything specifically. So I have a random set of numbers. I have 6 numbers random set of 6 different numbers. In order to find the mean absolute deviation of these numbers, the first thing I need to do is find the mean. Well, think back, 6th grade, how do I find the mean of something? Perfect. I'm gonna add all these numbers together and then divide it by how many numbers there are. So I'm gonna take 139 plus 161 plus 153 plus 142 plus 157 plus 130. And even though I know you can do this on a calculator, write out what we're doing at least this first time around, so you're not, when you're like, wait, what did I do from here? Okay. So step 1, we find the mean. Find the mean. Please use Desmos as your calculator. Do not use any other calculator. So 139 plus 1. Sorry. All right, so 139 plus 161 plus 153 plus 142 plus 157 plus 130 all equals 882. Then from there, I would divide it by what? 6, because there's 6 numbers. And that will give me 147. This number represents the mean or the average. So the average of my numbers is 147. That is not the answer. This is just step 1 of finding the mean absolute deviation. Number 1 reason people get this wrong, they just find the mean, and then that's an answer choice. Obviously, they're gonna want you to mess up. Oh, there's my answer. No, that's just the first step. But based on our definition, we're trying to see how far on average is each number from the mean. So step 2 is figure out how far each number is from the mean. Okay, if my mean is 147? Yeah. If my mean is 147, how would I figure out how far each number is from this number? Subtract, right? And remember, back to our definition, absolute. This is when we're taking the absolute value. We just want to see how far the number is away. So we don't want positive, we don't want negatives, okay? So when we're subtracting, so I'm just going to draw like a line. 139 and 147, when I'm subtracting that, I just want the positive value. I'm just trying to see absolutely how far away these numbers are from each other. So I can do 147 minus 139, or I can do 139 minus 147. It doesn't matter. It's just the positive value. So it is 8 away from each other because I subtracted these. So you do not want the negatives. Just change it to a positive if it's negative. 139 minus 147 is negative 8, but I'm just trying to see how far they are, so I'm just going to put 8. They are 8 units away from each other. Okay, 161 and 147, how far are they from each other? Don't depend on me to do all the calculations. 14 away? All right. How far is 153 from 147? 6 away. How far is 142 from 147? 5. How far is 147 from 157? 10. And then how far is 130 from 147? 17. So this is how far each number deviates from the mean. This is how far each number deviates from the mean. So step 1, find the mean. Step 2, figure out how far each number is from the mean. So subtract. Step 3, what is the mean of how far each number is from the average? So I'm just going to go back to this slide and do it on this slide. My next step is to figure out how far each of these numbers on average is from the mean. Well, I'm just going to take the mean of these numbers that I found. So step 3, find the mean again. Find the mean of all of these numbers right here. So 8 plus 14 plus 6 plus 5 plus 10 plus 17. So when I add all these together, it gives me 60. And then do what? Divide it by 6. And that will give me 10. So my answer is 10. That means on average, each number is about 10 away from the mean. On average, each number is 10 away from the mean. And that's all we're learning today. We're obviously going to do more examples, but that's it.
So it's basically just doing the same thing 3 times.
Absolutely. So if I was to be putting this in short term, if I made an acronym for this, I would say MSM. Why is it not? Okay, MSM. Oh, it's ugly. Now I got to erase that. Hold on. MSM. First, I find the mean. Then I subtract. And then I find the mean again. These are the 3 steps. Mean, subtract, mean. Find the mean, subtract, find the mean. Okay, I'm gonna do one more example with you, and then I'm gonna let y'all do a couple on your own, and then we'll move on to today's assignment. Okay, so I'm gonna do this first one, the one in blue. If you feel like you've got it, go ahead of me. If you need me to do it one more time slowly, that's what I'm about to do. So my first order of business is to take the mean of all these numbers. So 10 plus 7 plus 13 plus 10 plus 8. That will give me 48. So 10 plus 7 plus 13 plus 10 plus 8. And yes, if a number repeats, you do still include that number. So 10 plus 7 plus 13 plus 10 plus 8 is 48. Divide that by 5 because there's 5 numbers. 1, 2, 3, 4, 5. And that will give me 9.6. That is not my answer. That is the mean of the data. So my next thing I want to do is figure out how far each number is from the mean. So 10 to 9.6, that is 0.4. 7 to 9.6, 2.6, right? Yes, 2.6. 13, yes, ma'am. So I'm subtracting. So 10 minus 9.6 is 0.4. 7 minus 9.6 or 9.6 minus 7 is 2.6. So yeah, I'm subtracting because I'm trying to see how far each number is from each other. Yes, good question. 13 and 9.6. So I'm doing 13 minus 9.6. 3.4. 10 from 9.6. We already did that one. It was 0.4. And 8 from 9.6 is 1.6. So to get all of these numbers, I subtracted them from the mean because I'm trying to see how far each number is from the mean. From here, I now find the mean or the average of these numbers. So 0.4 plus 2.6 plus 3.4 plus 0.4 plus 1.6. That will give me 8.4, but then I'm dividing that by 5 because I was looking for the average. And that will give me 1.68. So the average distance, each number is from the mean, is 1.68. If you went ahead of me, did you get that? Awesome. Okay, I need you to ask me questions if you have them. Zoomies, can I get a virtual thumbs up if you're good? If not, I'm gonna take it as you have a question. Okay. All right, let's try the second one. Try the second one on your own. Try the second one on your own. Now, it is super easy to mess up on these. If you do one miscalculation in the calculator, it ruins the whole problem, okay? So make sure you're checking what you're writing in the calculator with this. Did y'all get 108.4 for the mean? Okay, so that's just the first step. So remember, when you're subtracting, even if it's a negative, just make it positive. All right, I don't know if I'm moving too slow or too fast, but I'm gonna go ahead. So you should have got 1.6, 5.6, 4.4, 0.4, and 2.4. And then finding the average of all these numbers. I cannot see my screen. 1.6, 5.6, 4.4, 0.4, 2.4 divided by 5. Did y'all get 2.88? Only Emily? Oh, you're still doing it? My bad. Thought I waited enough time.
I already finished on that one.
Oh, you already finished on this one?
Yeah.
All right, 2.88 should have been your average mean absolute deviation. What you're going to notice also when you look at answer choices, you shouldn't be getting big numbers or numbers that are close to the numbers that you start with. It should be like, it shouldn't be, like if you got 108, well, that number's too big. Your mean absolute deviation would probably be a smaller number.
I got 2.4, but I realized I got it wrong. It's 2.6 or like 1.
Oh, yeah. See, just one number, man, it throws the whole thing off. So yeah, this one have to be careful. I'm gonna be nice, and if start, well, did you already start this one?
Oh,
Okay.
I'm starting now.
You're almost finished. Okay, so you do this one, Jesus, but I'm gonna let y'all skip this one because this one's 10 numbers, so this would have been extremely long for y'all to do. Let's see, what time is it? 9:43. Okay, let's just do one more. Let's do this pink one, the bottom one. And Jesus, you can just finish this third one. Don't worry about the last one. Yes, baby. Oh, good question. Is that this one?
No,
Okay, 75.83. Let's just Just do it to 75.83. That's it. So let's just do the hundredths place on that one. Good question. And then zoomies, type your answer in the chat. 75.83. Let's everyone use 75.83. Zoomies, put your answer in the chat. Put your answer in the chat. So I'm gonna stop the recording.